So now I'm going to show you guys how to make a method. So when you open up the GCMS program, what you can initially see is that the method bakeout is loaded, which is awesome because it means that the person that was using the instrument before us left it in its state where it's very unlikely that any of their sample is still on the column because it's all been baked out. But what we're going to need to do for this sample is create a method that's specifically tuned to separate the components of the mixture that we want it to. So we're going to go to Method. We're going to load a different method because we don't want to potentially edit the bakeout method. And then we're going to go to a method of a fellow student from Chem 376. We're going to open it. And now that that's loaded, once we give the program a second to adjust, there it is. We're going to go to Method, Edit Entire Method. And this first window, we're not going to change anything. In the second window, we're going to describe a bit more about what our experiment is. So we have a mixture of toluene, DMF, which is dimethylformamide, and dichlorobenzene in DCM. DCM being dichloromethane. And then we're just going to hit OK. And this note is going to show up on our spectrum, which will just remind us of what it is that we're looking for. So now we're going to go to this next window. We're just going to hit OK. We're going to have to actually edit our method in this window. So the first thing we're going to check is that the gas is helium, because that's the gas that we have hooked up to the instrument. And then really the only other thing that we're going to be editing is oven. So right now the starting temperature and then the delay for that starting temperature is at 37 degrees, but the boiling point of our solvent, DCM, is 39.6 degrees. So we need this initial temperature to actually be higher than that so that we can get the DCM boiled off and into the column. And we only need to have it hold there for 2 minutes. Now, this ramp rate, additionally, because our melting point, the boiling points of our various components are spread out at 111 degrees Celsius for toluene, 153 for DMF, and 174 for dichlorobenzene, we don't need our ramp rate to be quite that slow. So we can do 10 degrees Celsius per minute. Now this last temperature, we only need it to be mildly higher than the boiling point of our final compound so that we make sure that everything is boiled off. And that the highest boiling point of any of our compounds is dichlorobenzene at 174 degrees Celsius, so we'll just set this to about 200 degrees to make sure that it ends up boiling off, but not that we're getting the oven too hot and just running everything through the column. The last thing that we need to check is that post-run, we have a bake-out of sorts, just to burn everything that's currently off the column, and 250 degrees for 5 minutes is perfect. We do not want to go higher than 250 degrees, as that is bad for the instrument. So since we've made some changes to this method, we're going to hit apply, and you can actually see that this is the ramp rate that's changed, and then here you have your post run. And we're just going to hit OK. We're not going to change anything on this window. Here we're going to make sure that we have atune.u selected, and then we're just going to hit OK. This is just to make sure that we have a solvent delay, which is important to make sure that we don't burn out the filament and prolong its lifetime. And as you can see, it's set for 2.5 minutes, which is perfect. We're going to just hit OK. Nothing here. And then here, we're going to hit cancel, yes, and then cancel again, which allows us to save. And so the first thing we're going to do is we're going to pick where we want to save our method to. So obviously we want it to be in Chem 376. And I think that should be as specific as we need it to be. Now we're going to name it something specific for ourselves, so we'll call it lmonibadge.m. And we're just going to hit OK. And now if you look to the top of the screen, you can see that our method has loaded and that the oven is cooling to our initial temperature. And so we'll just have to inject our sample and run it. So thank you.